We're going to learn how to solve simultaneous equations using a matrix method. This whole method is based on two things really. One is that when you have a matrix A and you multiply A by its inverse, you will get the identity matrix, right? So that's one thing that it's going to be based on. And then also the identity matrix multiply by any matrix. Well, that just gives you the matrix itself. So these two principles are what you use to solve a pair of simultaneous equations using a matrix method. Recall that the identity matrix is one of a two by two matrix, by the way, is 1, 0, 0, 1, right? Now for CSEC, you only need to know this for a two by two matrix. You don't need to do it for any other type of matrix, right? So again, it's based on the principle that when you multiply any matrix, when you multiply any matrix by its inverse, you get the identity matrix, which is 1, 0, 0, 1. And if you have a matrix and you multiply the identity matrix by that, you'll just get back the original matrix. So like, for example, if you had 1, 0, 0, 1, that's the identity matrix for a 2 by 2 matrix, and you multiply that. Let's say A is A, B, C, D. Well, when you multiply the identity matrix by A, you're just going to get A again, right? So these two things, these two rules of matrices, that's what we're going to use to solve a pair of simultaneous equations. So essentially, say you have a matrix A, another matrix X, and A times X gives us a matrix E, right? If I were to multiply both sides, so multiplying both sides of this equation, multiplying both sides or multiplying throughout by A inverse, well, that would look like this. A inverse times X, that's the left-hand side, is equal to A inverse times B, multiplying throughout by A inverse. Well, what I would get here, A inverse times A, remember, when you multiply a matrix by its inverse, you get the identity matrix. So this will give me the identity matrix times X, that matrix X, is equal to A inverse. And then, of course, we know that when you multiply the identity matrix by any matrix, you just get that same matrix. So the answer will be X is equal to A inverse B. This is what we're going to use to solve a pair of simultaneous equations using a matrix method. So let's see this in practice. So if I had the pair of simultaneous equations, so let's say I have 4x. So the first equation is 4x minus 5y, sorry, minus 5y is equal to negative 6, my first equation. And my second equation is 3x plus 2y is equal to 7. The first thing that you do is you obtain what we call the matrix of coefficients, or you could just call it the matrix equation, right? So what we do is we take the coefficients from x and y, and we're going to put them in matrix form. So here it'll be 4 minus 5. Then on the bottom for the second equation, it will be 3 and 2. And we put x and y here. This is equal to negative 6, 7. So I get a matrix equation, right? So here, A is 4 minus 5, 3, 2. X is xy, and then B is this matrix here. The answer is negative 6 and 7. So now I have this here, right? AX is equal to B. So I'm going to follow the same rules that I did here. I'm going to multiply both sides by A inverse. But in order to do that, I would first need to find out what A inverse is, right? And if you recall, A inverse is equal to 1 over the determinant of A multiplied by the adjoint, right? So that would be the determinant of A is the difference of the products of the diagonals. So the determinant of A would be 4 times 2, take away negative 5 times 3. That gives me 4 times 2. 4 times 2 is 8. Take away negative 5 times 3, which will be 23. All right, and therefore A inverse would be equal to 1 over 23 by the adjoint of A. Remember what the adjoint is, guys? We swap the first and last terms, so 2, 4, and we change the signs of the remaining 2. So it'll be 5, and this one will be negative 3. Well, before when we were doing the when we were looking at just finding the inverse of a matrix, we were multiplying out the fraction, the 1 over the determinant of A by each element in the matrix. But for the purpose of solving a pair of simultaneous equations, don't do that part because then you're going to end up with fractions inside there and it just gets very complicated. So leave A inverse as this for the while, right? And recall that. So we just, if we're looking at what we just talked about, if I multiply A inverse by both sides of this equation, right? So if I were to multiply AX is equal to B by A inverse, what would happen is on this side, on the left-hand side, A inverse and A will cancel off, remember, to give you the identity matrix, which will just leave you with X, right? So on the left-hand side, all you're going to be left with is X, which is, in this case, XY, and negative 6, 7 multiplied by A inverse. So really, what you're going to end up with here is just X is equal to A inverse times E. I'm running out of space, so I'm going to just come across here, right? So then X is XY. And let's multiply A inverse by B. So that's 1 over 23. That's by 2, 5, negative 3, 4. Times whatever B is, which in this case is negative 6, 7. So we're going to multiply the two matrices first. You do row by column, row by column. So this is a 2 by 2 matrix times a 2 by 1 matrix. Your answer is going to be a 2 by 1 matrix. So it'll be 1 over 23 times 2 times negative 6. So 2 times negative 6 plus 5 times 7. Then negative 3 times negative 6 plus 4 times 7. All of that will give me 1 over 23 times, well, let's check it, 2 times negative 6 plus 5 times 7 is 23. And then on the bottom, I have negative 3 times negative 6, which is positive 18, plus 4 times 7, which is 46. So my answer here will be 1 over 23 by 23 over 46. And once you reach this level, this part of it, you can now multiply that 1 over 23 by each term in here. So that will actually give me 1 over 23. So the xy is equal to 1 over 23 by 23, which will just give me 1. And then 1 over 23 by 46, which will give me 2. So my solution for this pair of simultaneous equations is x is equal to 1 and y is equal to 2. So I'm going to go through the whole thing again with you before I do another example, right? The first thing that you do when you have to solve a pair of simultaneous equations using the matrix method is you need to obtain your matrix of coefficients or your matrix equation. So you get that by just writing the coefficients in the matrix, right? So it'll be, for the first equation, you have 4x minus 5y. So 4 and minus 5 will go on the first row. And then in the second row, you'll have 3 and 2. So that would make up your matrix A. And then you use xy to be your next matrix. X is equal to, you put -6 and 7 in another matrix. So here you have AX is equal to B, right? Now, based on this, remember I told you this is the whole method of the whole matrix method of solving simultaneous equations is based on this, right? Based on the fact that when you multiply A inverse by A, you'll get the identity matrix. So, and then the identity matrix times any matrix is just itself. So what I will do, I will find the A inverse first, and then I multiply the whole equation, the whole matrix equation that I got by A inverse. So if you multiply the left-hand side by A inverse, all you're going to be left with is just X, because the A and the A inverse will cancel out each other. And then, well, you'll still have A inverse times B on the right-hand side. So what you do then is just do your matrix multiplication, multiply A inverse by B, and then you'll get your answer for X and Y. So the solution of this pair of simultaneous equations is X is equal to 1 and Y is equal to 2. Let's do another one. So suppose I had to solve 3x plus 4y. 3x plus 4y is equal to 27. And then 5x minus 2y is equal to 19. So my first step one, is to obtain my matrix equation. To get my matrix equation, I take the coefficients of x and y from the first equation. So that will be 3 and 4. And that will make up my row 1. And then coefficients of x and y from equation 2 will make up my row 2. So it'll be 5 and -2. That's my first matrix called A. Then I'll take x and y to make up a second matrix called X, and all of that would be equal to 27 and 19, the answers to the equation. And that is my matrix B. And let's just call this equation 1 for ease of to be able to follow through it properly, right? Once you get your matrix equation in this form, you multiply throughout by A inverse. So first, in order to multiply throughout by A inverse, well, we need to know what A inverse is. A inverse, if you recall, is 1 over the determinant of A multiplied by the adjoint of A. So this will be the determinant of A is 1 over, the determinant of A will be 3 times -2, take away 4 times 5. So that would be the determinant. I'm just writing it all out here, right? Times the adjoint. The adjoint will be where you swap the first and last term. So you'll get -2 here and 3 will go here. And you change the sign of the remaining terms. So -4, -5. Just to simplify our 1 over the determinant of A, 3 times -2. 3 times -2 is -6. Take away 4 times 5, which is -26. All right, so my determinant, 1 over the determinant will be 1 over, well, actually -1 over 26. So A inverse will be -1 over 26 by -2, -4, -5, and 3. One second, guys. All right. So next, I'm going to multiply equation 1 by A inverse. So multiply, going up here now, multiply equation 1 by A inverse. So that would mean that you'll do A inverse times A by X is equal to A inverse by B. A inverse times A gives you the identity matrix. So it'll be I times X is equal to A inverse by B. And therefore, the identity matrix times any matrix is just itself. So you'll just end up with X is equal to A inverse by B. Now you don't have to write these three lines that I just wrote there. I'm just writing it here for ease, for explanation purposes. All right. So now I go ahead. I'll have X, which is X over X and Y. So X is X, Y. The inverse I worked out as negative 1 over 26 by negative 2, negative 4, negative 5, and 3 times b, which is 27 over 19. All right, so then this would be xy equal to, notice I'm not multiplying by the fractionals yet. That's the last thing that I'll do. I'm just going to do my matrix multiplication here. So this will be negative 2 times 27. And again, I'm writing this out just for explanation purposes. Negative 2 times 27 plus negative 4 times 19. That's my first element. And then negative 5 times 27 plus 3 times 19. Simplifying that, I will get negative 1 over 26 times my matrix will simplify to be negative 2 times 27 is negative 54 plus negative 4 times 19, which is 130, negative 130. And then negative 5 times 27 is negative 135 plus 3 times 19, which is negative 78. And now my final step will be to multiply the matrix by the scalar 1 over negative 26. So xy would be equal to 1 over negative 1 over 26 times 130 is negative 5 and negative 1 over 26 times negative, oh, sorry, not negative 5, positive 5, because it's negative times negative. Yeah, so this will be 5, and then negative 1 over 26 times negative 78 is positive 3. So my solution for this pair of simultaneous equations is x is equal to 5 and y is equal to 3. Now, like I said, you don't actually need to write out this step, this one over here, right? I just put that there to just be a little more thorough. Right. So let's do another one. And then I'm going to give you all some to try. Right. So say we have 3x plus 2y is equal to 1. And then x plus 4y is equal to negative 3. First thing you need to do is get your matrix equation. So you put your coefficients in matrix form. So this will be 3, 2, then 1, 4, y, x, y. And this is equal to 1, negative 3. So the first matrix here is A. The second matrix is X. And this matrix here is B. So let's call this equation 1. Now we're going to find A inverse. So A inverse, as you know, is 1 over the determinant of A times the adjoint of A. All right, so the determinant of A here would be 3 times 4, take away 2 times 1. This would be 3 fours are 12, 2 times 1 is 2, so 12 take away 2 is 10. Let me just make sure, 3 times 4, take away 2, yeah, 10. All right, so therefore A inverse will be 1 over 10 times the adjoint of A, which is, you swap the first and last ones, and you change the signs of the remaining two. So that's your A inverse. Let's multiply the whole equation 1 by A inverse. So we're supposed to write this equation 1 over here. That's what equation 1 is, right? So multiplying equation 1 by A inverse, the whole left-hand side, you're just going to be left with y is equal to 1/10 times 4, -2, -1, 3 times b, which is 1, -3. I'm going up here now. So let's simplify this. Y is equal to 1/10 by 4 times 1, 4 times 1 plus -2 times -3 for your first element. And then on the bottom, -1 times 1 plus 3 times -3. So this is going to give me xy is equal to 1/10 by 4 times 1 is 4 plus -2 times -3 is 6. So this will be 10. And then -1 times 1 is -1. And 3 times -3 is -9. So -1 plus -9 will be -10. And now finally, I can multiply 1/10 by each element in the matrix. So it would be 1/10 by 10 is 1, and 1/10 by -10 is -1. So your solution is x is equal to 1, y is equal to -1. So I want you all to try one for me. Try for me 4x. I'm leaving the solution on the screen so you could kind of like look at it to make sure you're on the right track. So 4x plus y is equal to -3. And 3x plus 2y is equal to -1. So try this one for me, guys. Send it to me on WhatsApp as soon as you're finished, please. Right. So the question is, wait, which number is this? Number 4. Right. So it's, I'm going to do it still, even though some of you all sent it already. Right? It's 4x plus y is equal to -3, and then 3x plus 2y is equal to -1. Step 1, obtain your matrix equation. So that's going to be 4, 1, 3, 2 by xy is equal to -3, -1. Let's call this equation 1. All right, so this first matrix here, the matrix of coefficients is x. This one is x. Sorry, the matrix of coefficients is A. Sorry about that. XY is x, and then let's call this one E. Right? So first thing, let us find A inverse. A inverse, recall that A inverse is equal to 1 over the determinant of A times the adjoint of A. All right? The determinant of A here would be you multiply the diagonals. So you say 4 times 2, take away the products of the other diagonal. So 4 times 2 times, sorry, take away 1 times 3. So that would give me 4 twos are 8, 1 times 3 is 3. So 8 take away 3 is 5. So therefore, the inverse of A will be 1 over 5, since the determinant of A is 5, times the adjoint of A. Remember, with the adjoint of A, you swap positions with the leading in the leading diagonal. So 4 and 2, 2 will take the place of 4, and 4 will take the place of 2. And then you change the signs of the remaining terms. So -1, -3. That's your A inverse. And now we are going to multiply equation 1 throughout by A inverse. So we're multiplying both sides of equation 1 by A inverse. So as you know, when you multiply A inverse by A, that's just going to give you the identity matrix. So this whole thing will cancel out, and you would just be left with X and Y. So XY is equal to the A inverse, which is 1/5 by 2 minus 1, -3, 4. That's the inverse of A there, times B, which is -3, -1. And now you simplify. So XY is equal to 1/5 by 2 times -3 plus -1 times -1. And then on the bottom, -3 times -3 plus 4 times -1. Simplifying, you get xy is equal to 1/5 by, well, 2 times -3 is 6, -6, and -6, let me just write these in up here so you could see it. Right, so this here would be -6, and -1 times -1 is +1. So -6 plus 1. And then on the bottom, -3 times -3 is +9. And then 4 times 1 is 4 times -1 is -4. So we're going to end up with -6 plus 1, which is -5, and -9, sorry, take away 4, which is +5. So your final answer will be xy is equal to 1/5 times -5 is -1, and 1/5 times 5 is 1. So your solution, x is -1 and y is 1. Right, do another one for me. Try for me. 2x plus 5y is equal to -16. And then 3x plus 2y is equal to -2. Try this one for me, guys. Those of you who didn't send your work just now, please send it. If you didn't get through the first one and now I have the solution, copy it down and try number 5 for me and send it to me on WhatsApp. First thing, we obtain our matrix equation. And so we use any coefficients. So that will be 2, 5, 3, 2. Our matrix A. X will be xy. Then the next matrix, -16, -2. That is B. This is equation 1. First things first, we need to find well, this is the second thing actually. We need to find A inverse. Recall that A inverse is equal to 1 over the determinant of A times A adjoint. Right? So let's see, the determinant of A is given by subtracting the products of the diagonals. So 2 times 2, take away 5 times 3. So this is 2 times 2 is 4, take away 5 times 3 is 15. So that would be -11. Is that so? 4 take away 15. Yes, negative 11. All right. And A adjoint, I'm just writing this out separately just because I know some of you were not here last week, so I want you all to see as clearly as possible how we get the inverse. All right, first the determinant, and then A adjoint is found by switching the positions of the first and last elements. Now in this one, it's the same because it's just 2 and 2, and changing the signs of the remaining elements. All right, and then you put those together. So A inverse will be 1 over the determinant, so 1 over 11, negative 11, which will just be negative 1 over 11 by the adjoint, which is 2, negative 5, negative 3, 2. And now we multiply equation 1 by throughout by A inverse. So let's do 1 times inverse, both sides of the equation by A inverse will eliminate um, the the A. It will eliminate the matrix A. So you'll just be left with X is equal to A inverse times the E, right? So you'll be left with XY, matrix X is equal to negative 1 over 11 to negative 5, negative 3, 2. That's the inverse of A times B, which is negative 16, negative 2. All right, and now let's simplify this. So xy, the last thing you'll do is multiply by this fraction, right? So negative 1 over 11 is staying undone, and we're going to multiply our matrices. So that will be 2 by negative 16 plus negative 5 by negative 2, then negative 3 by negative 16 plus 2 by negative 2. Let's see what that gives us. Well, 2 by negative 16 is negative 32. And that would be plus negative 5 by negative 2 is positive 10. And then on the bottom, negative 3 by negative 16 is 48. Plus 2 by negative 2 is negative 4. So you're going to end up with x, y is equal to negative 1 over 11 by negative 32 plus 10 is negative 22. And 48 um, plus negative 4 is 48, take away 4, so that will be 44. So xy is equal to 1 over negative 1 over 11 times negative 22, which will give me positive 2, and negative 1 over 11 times 44 will give me negative 4. So that's my solution for this pair of simultaneous equations. So step 1, you obtain your matrix equation. Do that by taking the coefficients, right? So this would be 5, 2, 3, 4. Let's call that matrix A. XY, I'm going to call that matrix X. That is equal to negative 7, 0. That is your matrix B, and we'll call this equation 1. First thing that we need, well, the second thing that we need to do is to find the inverse of A. So if we recall, A inverse is equal to 1 over the determinant of A times adjoint. So the determinant of A would be 5 times 4, product of the leading diagonal, minus the product of the other diagonal. So this is 5 times 4, which is 20, and 2 times 3 is 6, so 20 minus 6 is 14. And then A adjoint would be, you swap the terms in the leading diagonal. So 4 would replace, well, 4 would switch positions with 5. So you'll have 4 and then 5 here. You change the signs of the remaining elements. And now you put that together for your inverse. A inverse is therefore given by 1 over the determinant, so 1 over 14 by A adjoint, which is 4, -2, -3, 5. Now that you have the inverse, you multiply equation 1 throughout, so both sides of equation 1 by the inverse of A. That is going to eliminate A, so you'll just be left with X on the left-hand side, which is, right, that would be XY is equal to 1 over 14 by 4, -2, -3, 5. That is the inverse of A by B, which is -7, 0. And now we go ahead and simplify. So XY is equal to 1 over 14 by, we'll say, row times column. So 4 by -7 plus -2 times 0. And then row by column again. So that'll be -3 by -7 plus 5 times 0. And all of that will give me, let's see, 4 times -7 is -28. 2 times 0, 0. -3 times -7 is +21 plus 0. So your final matrix there, when you simplify, would be XY is equal to, well, it's not the final as yet. 1 over 14 times -28 plus 0 is -28. And then 21 plus 0 is 21. So this would give me, finally, XY, 1 over 14 by -28 is -2. And then 1 over 14 by 21 would actually be 1.5, right? Because that will reduce to 3 over 2, 21 over 14. 7 into 14 is 2, 7 into 21 is 3. So 3 over 2 is 1.5. So X is -2 and Y is 1.5.